Hi there. This is Dr. Tech's recording. This is for cisp310, the Tuesday Thursday class in 2018 fall semester. And this recording is about question number 2 of the final exam. This question is about how to implement the JLI instruction without the JLI instruction. In other words, we want the branch to label LT if and only if the L flag is set, but we do not have the L flag. So let's go ahead and answer this question now. The first thing is we have to remember. So the first thing is we have to remember that the L flag, how the L flag is defined. So the L flag is the overflow flag, exclusive OR, with the sign flag. Okay, so that means the L flag is a 1 if and only if the O flag and the sign flag do not agree. They are not the same. Okay, this is not required, but you can also use a truth table to remind yourself how this works. So if here's an overflow flag, this is a sign flag, 0 0 1 1 0 1 0 1, and the L flag is the exclusive OR. So that means when they are the same, the L flag is a 0. When the O and the S flags are the same, the L flag is a 0. When they are different, then the L flag is a 1. So that's the truth table that we need to go for in order to define, implement the JL instruction, but only using JSI and JOI as instructions. There are not really too many different ways to do this. You're going to have to start with, because the objective is to implement just these two instructions, so there's really no comparison that we need to worry about. If you include additional compare instructions and whatnot, it doesn't matter. I'm not going to take any points off, but I will, focus on just the sequence of instructions to replace the JLI LT and the not LT colon labels. Okay. All right. So let's go ahead and start with JOI. Okay. So JOI. Now, when you use JOI, we can't really quite decide right away, whether we should go to the LT label or the not LT label, because all we can confirm is that the O flag is a 1. So I'm going to branch to a label called O1, which means the overflow flag is a 1. So that means if I get here, if I continue execution, that means the overflow flag is a 0. Okay, so I'll go ahead and label this and say that the overflow flag is a 0 in this case. So if the overflow flag is a 0, the only other conditional branch instruction I can do is JSI. Okay, so we say JSI here. But if the overflow flag is a 0 and then JSI takes place, that means the L flag is in fact set. So that means we should go to label LT, because this is one case where the L flag is set, because the overflow is a 0, the sign flag is a 1. So if I want to correspond to the truth table here, this corresponds to this case here. All right. So what if we're not branching? What if the sign flag is also cleared? Okay, so if I write comments here, at this point we know that the okay, let's back up a little bit. We know the sign flag is also a 0 here, so that means the L flag is also going to be 0. If the L flag is going to be 0, then we're going to do a JMPI to not LT, which is a continuation. Oops, we don't need the colons over there, which is a continuation of the code. Okay, so now we need to look at, okay, what if we branch to this O1 label from earlier? Well, if we branch here, that means the overflow flag is known to be a 1, but I can only do a JSI after this because that's the only other conditional branch instruction that I can use. So if the overflow is a 1 and the sign flag is a 1, then I also have to go to not LT because that corresponds to the other case. I'm going to use a different color here. So sign and overflow are both zeros. Is this one? Okay, that's corresponding to this, and them both being ones is corresponding to this. All right, and I think I just made a mistake here. Well, maybe not. Okay, it wasn't a mistake. So the only thing left here is a JMPI instruction. So what if the sign flag is a 0? Okay, so that means um, the overflow is a 1, the sign flag is a 0, so we should go to label LT in this case. So if I were to label this one, it's going to be like that. All right, one more thing to do because we have to define, oops, okay, my palm touched the other window first before my pen has contact with the screen. So we have to now define not LT over here because in the original code right here, see how not LT is defined as a label. So we have to continue that. Okay, we have to keep that here, and that's it. That's the whole sequence of code to get it done. So the grading that I'm gonna do is to examine all 4 cases of um, the overflow and the sign flag and see whether your code is going to work for all 4 cases. So I would be checking for, is your code indicating that you understand how the L flag works? Does your code indicate that you understand how the conditional branch instructions work? And also, does your code indicate that you know how um, TTP-ASM code works in general in terms of syntax and stuff like that? So that's how your answer is going to be graded. And after the exam, I think most people, confirm with me that question number 2, which is the question that we're talking about right now, is one of the easiest questions of the entire test. That may or may not be the case. I just wanted to make sure that people understand the conditional branch instructions and also understand what JLI really represents. Um, all right, so when I have time to grade another question, I'll post another video. And right now I'm going to go to Canvas and set up the rubrics and then start grading this particular question.